In this video, we will talk about the application of right triangles trigonometry, and we'll be using the sine, the cosine, and the tangent ratio to solve some real-life situations. So let's take a look at some examples. Let's take a look at this example under the introduction, and let's understand what is being asked here. It says a wire or a guy wire is attached to the top of a 75-meter tower and meets the ground at an angle of 65 degrees. How long is the wire? So here we have a visual representation of the situation that we do have here. The first thing I want to do is just identify what is the wire and everything that comes with this problem. This a wire is attached to the top of a 75-mile tower or meter tower. So here, this line right here, it's what's going to be representing a wire. And now notice that in this same diagram, it says it's attached to the top of a 75-meter tower. So in this case, this is our tower. And more importantly, it also states that we are creating a 65-degree between the wire and the tower. And now the question is, how long is the wire? So pretty much we want to find out the distance between this point and this point. We just want to find out the total length of this wire. But usually towers are done in a straight, they're done vertically to the ground. So if they're done vertically to the ground, we know that that's 90 degrees. And now if we step out for a second, notice that we essentially have the right situation to use the sine and cosine ratio, because we can treat this as if it was a right triangle where this is 65 degrees. This is my opposite because this is the angle of reference. That's my opposite. This is my hypotenuse and this is my adjacent. And notice that what we want is the length of the wire, which in other words, we want the hypotenuse of this right triangle. So notice that what we want is the hypotenuse, and what we do have is the opposite of this 65 degrees. So now let's think about the different tools that we do have that we have discussed in our previous class. We know that the sine of an angle, that's equivalent to opposite over hypotenuse. We also know that the cosine of an angle, that's equivalent to the adjacent over the hypotenuse, and also the tangent of this angle is equivalent to the opposite over the adjacent. So now let's think about this for a second. We have the opposite and we want the hypotenuse. So if we take a look at the three different ratios that we do have here, which of the threes we can use? Well, we definitely want to use the ratio that it is defined in terms of the opposite and the hypotenuse, which in this case it will be sine, because notice that sine is defined as opposite over hypotenuse. This is what we have. We have the value of the opposite, and this is what we want. We want the value of the hypotenuse. So let's set this up now that we have properly come up with the right trigonometric function. So we're going to be using sine, but the sine of what? The sine of 65 degrees, because that's going to be equal to the opposite side, which is 75, over the hypotenuse, which, let me represent this length as x. And I notice that we can solve for x now. The way that we want to solve for x is we're going to multiply x on the left, we're going to multiply x on the right. That cancels out. So now we know that x times the sine of 65, that's equivalent to 75. But notice what we want to do is we want to leave the x by itself. So therefore, we have to divide by the sine of 65. By doing that, this cancels out. So now we know that x is equivalent to 75 over the sine of 65. And this is something that we can use a graphing calculator to find. So we got 75. So we got 75 divided by the sine of 65. And now we know that x is equivalent to 82.7. And again, if it looks weird, the first thing I want to do is make sure that it's in degree mode. That is fine, so we know we're okay. So that means that the length of this wire, it's of a value of 82.7. In this case, notice that this 75 is given in meters, so we know that 72.5 meters. So don't forget your units. And let's just take a look at another example. Let's pick a number randomly. Let's take a look at example 3. Because now we want to, the first thing that you want to understand from these problems is to actually understand the situation. So it's always good for us to draw a diagram. So let's see, what is example 3 talking about? So it says the angle of a cable from a point, I think there's a typo here, they should say from a point, is 12.5 meters from its base is 52 degrees. So what exactly does this sentence mean? What this sentence is saying is that we have a point and there is a base, or at least this is where our cable is going to be attached. So we have our base, and now what this is saying is that we have a cable here, which is attached to a point. So this is the cable, this will represent the cable, and this will represent our base. And what we know is that this point is 12.5 meters from its base. So notice that this is what it's trying to say here. So here what it's trying to say is that we have a cable. Here we have a cable, which is going to be represented by this line, which is 12.5 meters away from its base. But the base is going to be this figure that I just drawn here. So this is our situation. And again, notice that if it's the base better be perpendicular to the ground. So we have a right angle here. So now we can think about this as if it was one of those right triangle problems, because here we have a right triangle. And I guess I forgot to mention that the cable creates 52 degrees from the base. So here we have a right triangle, which we know that this angle is a value of 52. And now the value of the base will be the opposite of 52. The cable is represented by the hypotenuse, and now this side is the adjacent. And again, what we're looking for is the length of the cable, which in other words, we're just looking for the hypotenuse. So now we think about the three ratios that we do have stated previously. Notice that I have the value, I guess I forgot to write it here, 12.5. I have the value of the adjacent and I want the value of the hypotenuse. So if we take a look at our ratios here, which of the three ratios talks about adjacent and hypotenuse? So notice that we cannot use sine because sine uses the opposite, the value of the opposite. And that's something that we don't have. We don't have the value of the base, so we don't have the opposite of the triangle. Same idea, we cannot use tangent because it uses opposite. But if we use cosine, which has adjacent or hypotenuse, this is what we want. This is what we have. We have the adjacent, and this is what we want. We want the hypotenuse. So definitely for this problem, to solve it properly, we're going to be using the cosine function. So let's state it. The cosine of 52, cosine is defined as adjacent over hypotenuse, where adjacent is 12.5 and the hypotenuse is what we're looking for. So now that we have this set up properly, we just gotta solve for x. So how we're gonna go about it? Let's multiply x to both sides. So now this cancels out. And now we have that x times the cosine of 52, that's equivalent to 12.5. And again, notice that we're solving for x, so therefore we're going to divide by cosine of 52. Now this cancels out. So now we have that x is equivalent to 12.5 over the cosine of 52. And now we use a graphing calculator to find this value. 12.5 divided by the cosine of 52, that is going to give us a value of just 20.3. So now we know that the length of this hypotenuse, the length of this scale, which was represented by the hypotenuse, it is of a value of 20.3 meters.